Hi, welcome to Elonix. In this episode, we'll make a touch alarm circuit on a breadboard using 555 timer IC. In order for this circuit to get triggered, it should get in contact either with your hands, fingers, etc., or with negatively charged objects. It is also sensitive to indirect contact and also detects electrostatic charges when they are very near. We'll learn how this circuit works later in this video. For link to the circuit diagram or any other information, please refer to the description below. I'll be using this row as positive rail and this as negative rail. Place 555 timer IC on the breadboard with its notch facing up and the pinouts are as shown. Connect pin 4 of the IC to positive rail and pin 1 to negative rail. Connect the reset pin, which is at pin 4, to pin 8. Now connect pin 6 to positive rail and connect a touch contact at pin 2 of the 555 timer IC. You can use any connecting material instead of this copper wire. Next, place an LED on the breadboard. Connect its anode to the output of 555 timer IC and its cathode to negative rail via a series resistor. Find out the value of this resistor from this table. Now connect a buzzer between the output of 555 timer IC and negative rail. You can test the circuit we have built so far by connecting the power supply and touching the sensing wire. So the circuit detects physical contact as expected, and the next thing to do is to latch this circuit so that the output stays on continuously. For doing that, we'll use an NPN transistor. I've used a BC547 transistor and placed it such that its emitter pin is directly connected to negative rail. Now connect the base of this transistor, which is the center pin, to pin 3 of the 555 timer IC via a 10K resistor. Next, connect the collector pin of transistor to pin 2 of the IC. If we connect the power supply at this point, the circuit triggers immediately after the power supply is turned on because of initial changes in voltages at the pins. So we need to add a kill switch that resets the output whenever required. For this, I used a momentary push button switch, connected one terminal to pin 2 of the 555 timer IC and the other terminal to positive rail. The circuit is now ready and use any power source between 5 to 15 volts to turn it on. Let's now try to understand how this circuit works. In the previous video, we used the voltage detecting capabilities of pin 2 and pin 6 to make a touch on touch off circuit. In the process, we learned that if a voltage more than 2/3 of the supply voltage is applied at pin 6, it turns off the output. And if a voltage less than 1/3 of supply voltage is applied at pin 2, it turns on the output irrespective of the voltage at pin 6. For this project, we just need to turn on the output immediately after there is a contact with a touch wire. So pin 2 is the ideal choice for connecting the touch wire as it turns on output whenever it sees voltage near 0 volts or any negative charge. And the output should normally be in off state whenever the circuit is not triggered, so pin 6 connected to positive rail so that it always sees a voltage greater than 2/3 of supply voltage and keeps the output off during idle time. So far, the circuit detects electrostatic charges and tiny voltages applied at pin 2. Now we want the circuit to stay on continuously immediately after it detects a contact. The easiest way of achieving that is by creating a feedback mechanism between the input and output. Whenever the output turns on, we need to invert that signal to 0 volts and apply it at the input. So even after the object in contact is removed, pin 2 sees 0 volts and keeps the output on, and this in turn causes the voltage at pin 2 to be at 0 volts, and this forms a loop. For this purpose of inverting the output signal, we used an NPN transistor. So whenever the output turns on, the transistor gets activated because there is a positive voltage at its base and starts conducting between the emitter and collector pins, causing it to apply 0 volts to pin 2 of the 555 timer IC. And that's exactly what pin 2 needs to keep the output stay on continuously. To break this loop, we need to manually apply a positive voltage at pin 2 of 555 timer IC, which happens when we press the push button switch. In the next video, we'll further use this feedback mechanism to make a tap on tap off switch, which can also be called as knock switch, and convert it to a touch switch that works with just a single pair of touch contacts. Thanks for watching, do subscribe and have fun.